I have the notes that way.
You can maybe annotate them if you would like to. Annotate these? Yeah. Make any additional things, okay? All right, so let's start. First, we have our standard linear function. Again, like I told you a minute ago, you've seen y equals mx plus b. We're going to write it as ax plus b. Now, if you remember from function notation, we said that every single constant or constant coefficient will be represented by a different letter. So if you think back, we talked about function notation as f of x equals a x to the n plus b x to the n minus 1 plus c x to the n minus 2 dot 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 and so forth. So if you only have two different parts or two different terms to a function, all you need to use is a and b. Again, so this is like only looking at this part of the standard function. Once we get to a third part, we're in quadratics. Once we have a fourth part, we'd be in quartic or cubic functions. Once we have a fifth part, we'll be in quartic functions and so forth. But for now, we are simply looking at this portion. We are looking at this portion of our function. Again, the simple reason is because we only have two terms here. We only have two terms. Now in this case, n would just be a 1 right here. So 1 minus a 1 right here would make this go to 0. That's where the b just comes from. So this is ax to the 1 plus b, which is what we have right here. So we're only looking at the first two parts of our function notation today. Now, as we said a minute ago, everybody, what is the value of b? Good, the y-intercept. And what was a again? Okay, the slope. Let's just write that down so we have that clarified. So b represents the y-intercept, a represents the slope. Now, who can tell me why b represents the y-intercept? Don't tell me somebody told you that, but why does it represent the y-intercept? Okay, but yeah, tell me why or tell me what. The question is why. This is a tough question. It's not an easy question at all. Most people don't know why b is the y-intercept. Julia?
Isn't it like if you have a number there, like that's where you start on the y?
Okay, and that's what I'm asking why. You're telling me what to do with the b, right? But I'm asking you why is b the y-intercept? Not what do you do with it. Say it one more time. That's just notation. That's not the reason why. At your y-intercept, what is the value of x coordinate? What is it? 0. So, if x were 0, everybody, cover this up. What are you left with? You're left with b, which is your y-intercept. Again, the y-intercept, and we're going to talk about this in concept 17. We're going to talk about intercepts and methods. But if you ever want to think about the y-intercept, you set x equal to 0. And we'll talk about this again in 17. If you set x equal to 0, all you're left with is f of x equals b. Or in this case, y equals b. So this is your y-intercept at all times. It is important that you understand where that comes from. It is not just randomly assigned a value. The reason it is the y-intercept is because when you set x to 0, the ax term drops off. It goes to 0. So we can automatically cross that part out. And what are we left with? We're just left with y equals b. Okay? So again, the y-intercept is b because when x is set to 0, your equation results in simply b. All right. Let's look at types of slope and let's discuss what slope actually is. If we have some sort of a graph, and we're going to sketch, we'll use actual graphs in a minute, and you have a line that looks like this, somebody tell me the definition of what slope is. What slope is? Vanessa? Okay, the rise over the run. So A is the rise over the run. Anybody else with another definition or another interpretation? Because there are many interpretations. What is it? Not x over y.
Delta y over delta x.
Very good. Delta y over delta x. Be careful, John. You said it backward. Delta y over delta x. What does delta mean? Change. The change in the y value over the change in the x value. The rise over the run. So here, this is my run. This is my rise. The rise is also defined as your delta y, or the change in the vertical component. The run is defined as delta x, or the change in the horizontal component. It is important to understand the words vertical and horizontal are synonymous for y-axis and x-axis, or dependent variable and independent variable. So again, our slope measures the steepness of the line. Again, the slope measures the steepness of the line. If I have a slope that looks like the graph on here, and then I graph another slope next to it, and I graph this slope, or this line, to look like this, what can you tell me about those two slopes, or how can you relate them to each other? Jason? They're both positive. Very good. Very good. They're both positive, and we haven't even gone over that yet. Derek? They intersect. Yes, they do intersect with one another right in the middle. Very good. But what about the slopes? How can you relate them to each other? Give me a statement that makes some sort of relationship between these two slopes. Don't overthink it. I'm not asking for a lot. Give me a statement that relates the two values of the slopes here. Luis? Very good. So the line that is drawn in the black line has a higher slope, or a steeper slope. Again, we don't know what the value is. I have no idea what the slopes are. But if I call this slope A1 and I call that slope A2, I know that A1 is greater than A2. It must be, because it is steeper. Again, A1 is greater than A2 because it is steeper. It is good to understand the relationship between slopes. So you can see that as you tilt something, what are you doing? You're increasing the slope or increasing the steepness of the line. Now, when we have negative slopes, it's a little bit different, but it's just a reverse. So we can look at more negative values. So again, slope is our rise over our run, or our change. Our change. So what is the change between this point and this point? Now, another way of thinking about slope is called rate of change. The rate of change of something. So remember in physical science, you guys talked about velocity equals x over t. In the beginning of this year, we quickly talked about v equals x over t in like concept 3 or 4. Velocity is a slope. And if you remember the graph that we looked at in the beginning of the year, we said x is the distance, t is the time. And if the distance is increasing like this, the slope of this line here, the slope of this is actually called your velocity. Now, you don't have to have that memorized right now, but it is good to see where do slopes come into play. So as you're driving in your car, the velocity of your car is measuring the average rate of change of your displacement, or your distance in this case. So if you're going at 50 miles per hour, that means that you're going literally 50 miles every hour. So for 2 hours, you'll be going 100 miles. For 3 hours, you'll be going 150 miles, and so forth and so on. So in this case, this is one example of an application of where we see slope. Okay, let's take a look at some examples of slope. First, we have 4 types. Somebody tell me the 4 types of slope. Derek.
Positive slope.
Good.
Negative slope.
Good.
No slope.
No slope. What does that mean? What does it look like?
Zero slope.
Very good. Horizontal line, 0.
Definite.
Undefined or infinite. Very good, guys. Okay. So again, this is a positive slope on the upper left. The easiest way to think about it is this. Look from left to right. The graph itself is literally going up. Think about it that way. From left to right, what is happening? It is going up. Thus, it is a positive slope. This one, it is coming down, or it is falling. So this is a negative slope. Okay, a negative slope. Over here, is this slope changing at all? It is not changing. And think about it this way, if you're having any trouble with this last one here. Delta y means the change in the y value. There is no change. This is delta x here. Delta x could be any value. But the delta y, there is no vertical change. So if you think about slope as delta y over delta x, there is no delta y. So it's 0 over some value, whatever delta x would be. But 0 divided by anything is still 0. So this slope here is a slope of 0. Okay, the slope on the left there is a slope of 0. Now, this slope on the right is what?
Undefined.
Undefined. Why?
Well, not
Use the previous example that I just went through to tell me why that's undefined. Jason? Very good, very good. The slope here, we have a delta y value. It goes up by a certain amount. Does it move over, though, in the x direction, ever? There is no delta x in the horizontal direction here. There is no value of delta x this way. It does not exist. So we have some delta y over 0. And as Jason just said, you can't divide by 0. Thus, we call this undefined. Okay, and later on, you're going to talk about how this is an infinite value. Okay, when you get onto pre-calculus and calculus, you'll talk about the theory of infinity. But for now, we can call it undefined. So those are our 4 types of slope. It is extremely key that you understand that the minute you see a graph, you know what kind of slope it is. When you see a graph like this, it's positive. When you see this graph, it is negative slope. It is very important to know that. It will make graphing a lot easier. I'll tell you that right away. Because you know how many students try and graph a line and their slope is like 3 over 2. Okay, so 3/2, it's a positive value. And their line does not look like a positive value, it looks like a negative value. So that's the key right away to know, okay, I made a mistake somewhere. I did my wrong delta y or my wrong delta x here, I have to fix it. Okay, next. We can have 2 lines that are parallel to one another. And the symbol for parallel is these triangles, if you remember from geometry. Now, if 2 lines are parallel, what can you tell me about the steepness of those lines? They're the same, because take a look. If you're walking up this hill, it's going to take you the same amount of energy to walk up that hill. They have the exact same steepness. So their slopes are the same. Again, their slopes are the same. So if we call this A1 and call that slope A2, what can we say?
A1 equals A2.
Very good. A1 is equal to A2. Again, the slopes of the line are the same when they are parallel. Now, the other one that is the trickier one, not for any reason but simply memorization, is if the lines are perpendicular. Vic, what do you got? Good, they're inverse. What else about it? Negative inverse or negative reciprocal. So let's write this down. So if this was A1 and this slope was A2, we can say that A1 is equal to negative 1 over A2. Again, this means inverse. Whenever you put something as 1 over, it means the inverse of it, or the reciprocal. I put the negative there because take a look at these slopes, guys. One of them is positive, the other one must be what? Negative. So right away, if you forget that it's negative reciprocals, look at the lines. This one is positive. If this one is positive, this one is negative. You have to have that negative sign there. So if you forget the negative sign, it's not even going to make logical sense. Your answer doesn't make sense if you forget that negative. And many people remember the reciprocal, but they forget the negative. Look at the graph. If one is going up and the other is going down, they must be negatives of one another. Okay? They must be negatives of one another. Questions on this so far? Okay, again, these are the basics that I'm going through, I said I would. Okay, you've learned all this before. You've seen it in both your last 2 classes. You learned all of this before?
You said these are the basics. I said I would.
I said I would.
You didn't say go. You said these are the basics. I said I would.
Oh, sorry. All right, let's look at an example.
It sounded like Yoda.
So, for the following examples, here's what I want to do. We want to find the slope and the y-intercept. Again, for the next 2 examples, let's find the slope and let's find the y-intercept. We're not graphing yet. We'll get to graphing in a second. So let's say we have an equation that says 5x plus 2y equals negative 4. And I'm going off the notes if anybody's following, just so you guys can keep them on. Here, before we even get into finding the slope and y-intercept, if the equation is written in the way that we're seeing it right now, we can call this an implicit equation. And let me explain these 2 terms real quick, because nobody ever really talks about this, but it is important. You have explicit, not like explicit lyrics or anything, and implicit. Okay? Explicit means the function is solved for y. So an explicit equation looks like something like this. Y equals 2x minus 1. Whereas an implicit equation, an example of that would be like 3x plus 4y equals 7. Pretty much the second equation just is not solved for y. So implicit, it is not solved for y. Explicit, it is explicitly solved for y. Okay, you can see what y is. But again, implicit, it is not solved for y. So our goal, if you remember, to find the y-intercept and the slope is to get into y equals ax plus b form. So we need to go from the implicit form to the explicit form. That's what we're doing right now. Okay, we're going from the form that it started in, and we want to move it up to this. Now, these are not the same graphs. These are two completely different examples. Don't let that confuse you. Okay, but in a second, you're going to see how we started with this implicit equation right here. And in the end, when we get an answer, it will be an explicit equation. Okay? Again, we started with an implicit, we will get to an explicit. Yes? Now, implicit, like this, is actually also called standard form. But we're going to wait till tomorrow to talk about that. But when it's something x plus something y equals a constant, we can also call this standard form. Okay? And we call this down here at the end, we're going to call this slope-intercept form. Okay? We'll call that slope-intercept form. We haven't even gotten to the answer yet, but just so we know what we're going to get to. All right. If I want to put this in slope-intercept form, again, I need to solve for y. What would my first step be in this equation here? Julia? Okay, minus the 5x. I absolutely agree with her. Okay? Here's my reasoning. Look at the coefficient of y, everybody. It's a positive 2, correct?
Yes.
So if we can get the 2y by itself, all we got to do is divide by 2 then. Okay? Now, that's the reason I'm going to move the 5x over. Now, when I move the 5x over, be careful. So if I say subtract 5x, subtract 5x, let's put it in an order that actually makes sense here. I could write negative 4 minus 5x, but that's not the way we talked. Jason, what should I do?
Negative 5x minus 4.
Very good. Negative 5x minus 4. Yes. Okay, so you always just get a drink of water. That's fine. So again, negative 5x minus 4. It does not matter really. It could be negative 4 minus 5x. But if we want to look at ax plus b form, let's put in that form to start. Now, what should I do next? Divide by 2. Okay, now, this is where it's actually worthwhile to divide into both. Remember how for the inverse function, you guys said just leave it like that? That's okay. But I showed you guys how you could divide the 2 into both. This is where it comes into play. And let's show why. Well, not why like that. Let's show how. Where does that come from? Somebody explain that last line there. How did that come about? Where did this, for example, how did we get from this line to this line? I know it seems simple to most people, but I just want to make sure we all get it. Daniel? In both, okay? Again, but it's in both. You don't know how many people would do this. Look, this is the common mistake. People cancel the 2 and the 4, and then they leave the negative 5x alone. If you have a monomial in the denominator and a binomial in the numerator, you must divide the monomial into both terms of the binomial. Again, you must divide the 2 into both terms of the numerator. So negative 5 divided by 2. You can't, I mean, it's negative 2.5. So you could write a decimal there, sure. But since I remember slope is delta y over delta x, this is in the form that I wanted it. My delta y is my negative 5. My delta x is my 2. Does everybody see what I'm saying here? There's no need to convert to decimals here. If anything, it actually makes it more complicated. Because then you'd have negative 2.5, and then you got to figure out, okay, what does that actually mean? That means I go down negative 2.5 and over 1. It's much more work than you want to do. Leave it in form of a fraction. And it's now your delta y is negative 5, go down. Your delta x is positive 2, go over. And this negative 2, again, represents what?
Where you start.
Where you start, good, or the y-intercept. Okay? So again, if I were to define the slope here, you're asked to find the slope. Again, the slope is negative 5 halves. The y-intercept is negative 2. Make sure you don't forget that little negative sign. Simple enough? Okay. Let's just do one more. I have 2 more on your notes. I'm going to do one more of the next 2. If we have 2x equals 3y minus 7. Okay, 2x equals 3y minus 7.
Add 7.
I would add 7 also, right? Because what's the goal? To get what by itself? Y. So get rid of what's around y. Okay? Now, divide by 3. I'm going to leave this blank. I want somebody to raise their hand and tell me the best way to represent this equation. What is the most efficient or optimal way to represent this equation? What should I do right now? Okay?
You want me to just give you what it
Just read it.
2 over 3x plus. I didn't do it.
What should I do with this part, guys?
2.3.
It's not 2.5, but what is the decimal value?
2.3.
2.3 repeating. 7 over 3 is 2.33333. Now, this is where it's important to put an actual decimal because what does 7 over 3 mean as a y-intercept? Are you going to be able to graph 7 over 3 if you don't know what it is? You need to know the decimal representation because it's your starting point. It's the height of the function where you start. So here, it is important or it is valuable to use a decimal. Again, I'm trying to show you guys little techniques that will make things easier on you. So it is not really valuable to have 7/3 in it. What is 7/3 when I'm graphing a number? Okay? 2.333, that tells me I'm 2 and another third of the way up. Okay, I'm 2 values up and another third of the way. So when I'm to graph this, and I'm not going to actually graph this, but this is my y-axis. I'm just going to graph the y-intercept first. If I were to graph this, this is 1, this is 2, this is 3. I have to go up to 2 and then go another third of the way. That's my y-intercept right there. It is important that you know what this fraction is. 0.3 repeating is a third. So this means this fraction is really 2 and 1/3. How do you graph that? Go up 2 and then break this into thirds. So break this interval into thirds. There's the first third, there's the second third, there's the third third. Okay? Again, it is extremely important that you know how to graph fractions also. They're going to show up. Get over the fact that everything's a whole number. Things in life are not whole numbers. Go to the grocery store. How often do you see a whole number? Usually you see like $1.99 for this item, $2.99, $2.50. Usually you have decimals and fractions in life. Go to a gas station. It's never going to be $4 a gallon for gas. It's always like $3.35, $3.65, $3.52. And even then it's .999 after that. Okay, if you take a look at the gas station prices, it's always .999 after that, so they get an extra cent out of you every time. It's true, they do. You guys ever notice that? You see the 9 repeating afterward? So whenever you think it's like $3.50 a gallon, it's actually like $3.51 a gallon. Okay? Because it's $3.50.999 repeating. It's funny because somebody actually a long time ago said, what would happen to the oil industry if they dropped off that 999? Right? They would lose a penny on everybody. It doesn't seem like a lot. It would be like billions and billions of dollars, that 1 penny every time. It's pretty interesting to think about that. Now, again, when you have a fraction, break up that component. You don't have to show this, guys. You don't have to break it up into 3 parts. If you know how to do it, then just do it. Okay? If you need to show it, then show it for yourself. Whatever you need to do to help you. All right. So that was the second example. There is a third example in your notes. I'm not going to go through it. We're going to go right out to graphing lines. We're doing well with time, guys. We still got 20 minutes. So let's do the examples of graphing now. And this is example 1 for graphing. We're going to start by giving you an equation, and then we'll go to the next slide to actually graph it on the graph. So here we have f of x, and the first one will be an easy one. I'm going to give you the actual explicit equation. The next one we'll try and solve for. Equals 1/3 x plus 2. Now, immediately, you don't have to write it down. If you need to, then do it. But if you want to, just think about what each thing means. So, right away, everybody, what does 1/3 mean? Slope, or the rise over run. Very good. And what does the 2 mean again? Good. The y-intercept, or as you guys keep saying, the starting point. That's a good way of thinking about it. It's your starting point. So, for this one, I know that my rise, or my delta y, will be 1. I know that my run, or my delta x, will be 3. And I know that 2 is where I start from. Okay, again, 2 is where I start from. So, using this equation, let's actually graph it now. So, 1/3 x plus 2. Again, that's the equation we're looking at right now. I'm going to go to the next slide. 1/3 x plus 2. So, if we are to graph this, and we want to graph plus 2 on here, where is plus 2? Jason?
second space.
Good, so I go up 1, I go up 2. There's going to be my y-intercept right there. That's a 1. I label this x. I label this axis y. Now, do I need to give any more numbers at all? You don't. Again, once you give actually, you don't even need the 2 here. Once you give the 1 in both directions, it tells me that all of your increments are by 1. Every box represents 1 unit. Now, if you wanted to do something different in the negative, that wouldn't really make much sense. Usually, if your x values go by 1 over here, they also go by 1 over here. If they go up by 1, they go down by 1 on the y-axis. So once you indicate the 1 and the 1, you don't need to start putting numbers everywhere. Now, it is useful sometimes to put some sort of reference point. So maybe 1, 2, 3, 4, like a 5 here, just to give yourself an idea of where 5 is. 2, 3, 4, 5. You can do that as well. But you don't even have to do that, okay? You don't have to go any further than putting a 1 on the x and y axis, especially when you're graphing on the SAT. Honestly, I wouldn't even put a 1 in those spots. If I were doing some sort of a graph for myself that was quick, I would just put tick marks everywhere. Put your tick marks along the axis, and you know that they're all by 1. If you're going by more than 1, then maybe indicate that. But don't waste your time, okay? Don't waste your time. Now, I started with my y-intercept again. That is my y-intercept. My slope was 1 over 3. Again, my slope was 1/3. So my rise over my run. Okay? Can somebody come up and draw this one for us? Here you go. Yes.
So it's like, just go up and then 1, 2, 3.
Very good. And give me another point in the other direction now. So you gave me a point up and over, now go the other direction.
Go down 1 over 3 to the left. Down 1 over 3 to the left. There you go.
Thanks for this.
Very good. Now it's important that we talk about what just happened here. Thank you very much, sir. Good. Okay. Most people right away know how to plot this point. Would you agree? You go up 1. Again, we go up 1 value, that's our rise. We go over 3, that's our run. And traditionally, that's the easier point to plot. Well, the other side exists as well. Because, well, who can tell me why the other way works? And don't tell me because it's a line. Look at your slope value and tell me.
You're going backwards to the opposite.
So what would the slope then be?
So it would be negative 1 or negative 3.
Good. Again, isn't negative 1 over negative 3 still 1 over 3?
Yeah.
What happens to the negative signs? They cancel. So think about this. We now went down 1, that's this value here, and we went left 3. That's that value there. That's where the second point comes from. But you know what? You don't need 3 points. How many points do you need to graph a line?
2.
Just 2. That was our definition of a line. A line is the connection between 2 points. That's all it is. Okay? So here, let me fit a line through this. We want a double-sided line, right? Let's see what this one looks like for a second. So if we were to, we're going to move it in a second. Let's grab the end of this line. Oh, we want to tilt this. Come on. Uh-oh. Crazy stuff's going on. Sorry, guys. Hold on. Here we go. Hold on. A little bit more. There we go. And it's a line, right? So the starting value should also be an arrow now.
This front seat sucks.
Okay? So again, we connected with a line. What should you guys be using when you graph a line? A straight edge, a ruler. Very good. So if you don't have a ruler, who cares? Use a binder. Okay? Use the side of your calculator case. Use your agenda case. Use your ID. Okay? Whatever you got to do. I do not want to see sloppy lines. That is the first thing that will bother me if I see sloppy lines. You have an infinite amount of straight edges around you. Pick one of them, please. Okay? It doesn't matter which one you use. Doesn't have to be a ruler. Next one. Try this one on your own, please. Again, you guys, you need to be graphing this after you find the slope of my intercept. Okay?
Mr. Howe, Mr. Cricket yesterday?
Yeah, what about it?
Jason hated.
Catch up and Bob John. Yes. Try this on your own. I know you have to go for it now. Just try it. Again, those of you that have the notes, that's fine, but I want you to try this on your own. So actually go through the process.
No, I know, I mean, like, when we get there, you do 5 minutes.
Because you're that's what the lights.
I got it.
Taking notes.
Oh, Jason,
Jason.
What? Give my old magazine back, son. Give my magazine back, son. Hey, Cub, my magazine back. Oh, C16. You put it on his backpack about 5 minutes ago. I watched you put it. No. Don't listen.
What do you think, man? It was like 10 minutes ago. You got like nonsense fish, constant memory loss.
But you're always like doing everything else. I didn't know you were doing
So it doesn't matter where you put it. I'm negative down here. I can go right. I'm going to show that. Same question? Okay, quickly. With a show of hands, who got the actual equation done by now? Not the graph, but the equation. Okay, keep working, guys. If you didn't finish, some people didn't raise their hands. I'm going to give you another minute. It is negative. Now, the negative go on the 3 or on the 2. We'll discuss why in a second. I want you to try and graph right now. Yes, sir. Very good job. Now, if you have a graphing calculator, which many of you do, feel free to go into Y1 and graph this already. And take a look at what the graph would look like. You can always check your graph on a graphing calculator. You have to be able to do it by hand because I want to see this, but I want you to be checking it on the calculator. Some of the ways that I learned in high school how to do certain things was just experimental. I sat there in the calculator and actually just changed the values of the slope and saw that as the slope went up, oh look at that, the line started getting steeper. Okay, so sometimes I was teaching myself things. You're welcome to do that kind of stuff, John, not now.
Why?
I'm going to answer why.
What? No, I just said.
Oh, they said why. I mean, that's a pretty easy answer. Okay, many of you got this answer already. Now, what you're going to notice is this. The negative 3 halves. I can think of it as negative 3 over 2 or 3 over negative 2. Again, I can write it the way you see it right now as negative 3 over 2, or I can think of it as 3 over negative 2. Okay, this is the same thing. This is the same thing as if there was a negative in front of the whole fraction. Either you put a negative in the top a negative in the bottom, or a negative in front of the fraction. It's all the same. But when you graph, this might indicate different things to you. To me, I go down 3 and to the right 2 for the first one. For the second one, I go up 3 and to the left 2. So depending on which one you're looking at, it doesn't matter. You're going to get the same answer. So let's graph it now. Who wants to come up and graph this one?
Yeah.
Can you do it with the left hand?
Yeah.
I'm thinking handicapped to do this. Right?
Whoa.
Sound like that.
She said she's on the DL right now, okay? Disabled list.
It's
She's
like
asking the game
disabled,
for
though. It's not
She got injured reserve. DL.
Mr. How like neat lines. Remember that? Use your cast. Oh, never mind. I know.
You want to connect that?
Do one more up top. I know we don't have to, but just for the sake of this. Again, you don't have to do 3 points. I'm asking her to do 3 just so we can see. Very good. Awesome job. Now, before we connect the line, let's go through this process. When you have a decimal as a y-intercept, don't let it trick you up. Many people get screwed up because this, right here. This is the value, 2.5 right here. So go down 3. Go down 1, that's 1.5. Go down another, that's 0.5. Go down another, that's negative 0.5. Then go over 2. Over 1, over 2. There's your point. Same thing this way. Go up 1, 2, 3, and go over 1, 2 spots. There's your other point. So your increments go by 1, sure. But in your mind, you need to be going by 1 on the half step. So since you started at a half step, every one of your next increase of 1 will land on another half step. So this is 2.5, thus 3.5, 4.5, 5.5. And in the reverse, 2.5, 1.5, 0.5, negative 0.5. And then your x value is 2. So you only have to go over 1, 2 whole units. Keep this in mind. This first point right here that she graphed, Vanessa went down 3 and over 2. That was this slope right here. Again, that was that slope. Now, she then graphed this point here. Well, she went up 3 and left 2. That is this slope here. And I should put an X here, sorry. There should be an X there. But that is the second slope. It does not matter which one you choose. Again, because all you need are 2 points. You got the y-intercept, pick one or the other point. It does not matter which one you choose. Okay, again, we connect this with a line. Why isn't there a double-sided line?
They have every line but double sided.
Pretty good, huh? Getting better. Oh, gosh. Okay, and it is a double-sided line here. It is a double-sided line, or double-ended.
There's an option to do that. You know,
Okay.
right? Like,
There's definitely an option. I gotta figure it out. I'll make a shortcut.
like right there. Like, reselect it. It's right there. Oh, never mind.
I don't see it. Yeah. This is a ray. This is a line without an endpoint, which makes no sense. This is a segment.
Well, you can get colorful with it.
Yeah, I'll fix it so next week it'll be there. All right. Does this make sense so far, guys? We okay?
Yeah.
All right. Immediately, what kind of a slope is this? By looking at the line, not the equation.
Negative.
Negative. Again, it's going down. It's going down. Okay. Before we get to the word problem, we have to do one more thing. We'll get to the word problem next. We have to learn what the equation of horizontal and vertical lines are. Now, many of you know it already. Don't give me the answer, please. But many of you know this. What I'm going to do is show you a way of thinking about it every single time. So, if I gave you a simple graph, and I told you that on this graph, okay, on this graph, there were points here, 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 and here. And I told you that this was at a height of 1, 2, 3. What can you tell me about all those points that they have in common? They have the same what, Vicky? The same y value. What is the y value, everybody?
3.
No matter what, isn't every point y equals 3?
Yeah.
Like, look at this one here. This will be 1, 3. This will be 2, 3. 3, 3. 4, 3. So every point for the y value is 3. Thus, the equation for a line like this is, very good, y equals 3. I don't want you to have to memorize. Like, it's good to know that a horizontal line is y equals whatever the number is. Again, any horizontal line is y equals that number. But in this case, just remember, what do all the points have in common? They all have a height of 3. A height is the y value, thus y equals 3. Okay, and clearly since we did that, you can all probably tell me the next one already, right? So if I give you a bunch of points that look like this. Okay, what would the equation of this line be?
Negative 2.
It would be?
Negative 2.
Good. What equals negative 2 here, though? X. Again, look at all your x coordinates. This is like negative 2, comma 1, negative 2, comma 2, negative 2, negative 1, negative 2, negative 2. So all of these values of x are negative 2. Thus, its equation is x equals negative 2. Okay, is that clear? Again, horizontal lines are y equals, vertical lines are x equals. Whatever point of the axis they go through is the value. So since this goes through negative 2, it's negative 2. Since this goes through positive 3, it is positive 3. Okay, let's go to the word problem now. Okay. What'd you say, John?
I went boink, 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 boink.
Wow.
Whoa.
Boink.
Whoa.
Just forget.
You like.
Boink.
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 Back to you.
Shoot. Where's my shit here?
You're so How? Boink. 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 Boink.
All right. So here's our example. If you want to write it down, it might be useful, okay? A taxi company charges $3 just to enter the cab, and many of you know this. Once you get in, there's already a fee on there. Just to get in, you actually get charged. Next, they charge 75 cents per mile. Determine the function that represents this cost, graph the function, and then determine the cost of a trip that is 8 miles long. Okay? This may seem intimidating. This is actually quite a simple example here. And we'll go through why it's easy. Help us out, John. Tell us what we got.
Would be y equals 0.75x plus $3.
Okay, John says y equals 0.75x plus 3. Tell me, why did you say that, John?
Because 70 is, you don't know how many miles.
Okay, it starts with, you don't, listen that, okay? You don't know how many miles.
Plus $3, which is just that's just it.
What is $3, guys? Your what? Your starting point. When you get in that cab.
I'm gonna knock this off.
When you get in that cab, it's $3 to start. What did we say the y-intercept was? The starting point. So 3 represents your starting point or your y-intercept. Now, every time you move a mile, how much does it cost?
75 cents.
75 cents. So each time your mile goes up by 1, your cost goes up by 75 cents. That is a rate of change or a slope. So, as John said, that is correct. That is our equation. So again, our cost function is C of x, meaning the cost at any value of mile x equals 0.75x, or 75 cents. This again is 75 cents per mile, plus an initial $3. Yes, Trayvon. Okay, and you can do that. Everybody hear what Trayvon just said? He put 0.75 over 1, so it looks like a slope. You know what, Trayvon? Make it even easier. Watch this. Instead of 0.75, why don't we just write 3/4? Isn't that what 0.75 is? So you know why I did that? Who can tell me why I put 3/4 here and not 0.75? Because now I have a slope, and it's a slope in whole number values. If you do 0.75 over 1, that is the correct slope, absolutely. But I don't want to graph 0.75 up over 1. I'd rather go up 3 and over 4, or go down 3 and left 4. So again, when you see things, if you saw 0.8, what slope would you write?
8/10.
8/10 or
1/4. No.
8.8. What's the simplest fraction for that?
4 over 5.
4 over 5. 8/10 is right, but reduce 8/10. You get 4/5. If you see 0.6, that's 6 over 10, but that's also 3 over 5. So reduce them to your lowest terms so that you can actually see the slope. Now, once you've got this equation, let's graph it. Let's just get rid of this now. Say again? Absolutely, you should. I recommend you do it. If you have a slope of like,
Is it 5/10?
yep, 1/2, absolutely. I wouldn't even give you, I mean, if you solve when you get 5/10, definitely reduce. So take a look quickly. So here's our function. Now, guys, if you're doing your homework and you want to make it look like this, that program that I told you about, GeoGebra, that free one, that's all I use to do this. Okay, it takes a little bit more work than just putting a function in because I put all this extra stuff. But again, our starting point was a value of 3. Notice, I didn't have 3 on the y-axis, but I have 2 and 4. Therefore, 3 is in between that. My slope was 3/4. Guys, we're almost done. Hold off for a second, please. My slope was 3/4. So I went up 3 and over 4. Again, my delta y was 3, my delta x was 4. Now, once I've graphed this function, and I want to know the cost after 8 miles, I can just look at my graph. I go on my x-axis, which is in miles. I notice this is my 8 miles. I go up, find the intersection, it costs $9. You can also plug it into the function. On your way out, make sure you take your homework worksheet, please. Okay, I'm simply going to put them over here so everybody can get that. Right next to the C. Take one each,
No, you stay over there.
Anna,
It's coming back now.
hang out for like 2 seconds. Tell me when you're taking the test.
I'm trying to think of it.
You need to take the test.
I remember that. I do remember that. I remember that. I was like, it's starting to come back
If you have something to do, somebody goes around and do that.
now. Who messed up?
No,
I left it perfectly at the start. What's the higher number you ever got to that? I got to 12 and it stopped me. Like, it wouldn't let me go to the next one.
Mr. Howell, you think this hardware now?
Awesome.
How awesome is this advance?